this video, we're going to be looking at 4 examples on creating exponential equations and using that equation to solve these problems. So number 1 says, suppose you have $300. So that $300 is your start, or your A. You invest this money into an account earning 6% interest each month. How much money will you have in 2 years? Well, first we need to know that this is an exponential growth. So you have to use this equation. Y equals A times 1 plus R to the power of X. All right, so recall that your A is your start value. So the amount of money that we start with here is 300. So I'm going to do Y equals 300. 1 plus my rate, or my R, is 6%, but we need to change that to a decimal. So if you're using decimals and you want to change a percent to a decimal, all you do is take that number and divide by 100. So that R value is 0.06. And then to the power of X, where X is time. Now, it does give us time. It says 2 years. But this is 6% each month. So we need to change those years to months. 2 years is the same as 24 months, meaning our exponent here should be a 24. Now that's all you have to type into decimals to get this answer. So we have Y equals 300. 1 plus 0.06 to the power of 24. Oops, that's not how you get a power. So you go down the keyboard and you're going to click the A times B, A to the power B, and that exponent should be 24. So our answer here is 1,214.68, which is D. So for this equation, notice we read the problem, we identified the A value, which is the start, we identified the R, which is the rate as a decimal, and we plugged all of that into this growth equation. So let's look at an example of a decay equation that we're solving. So number 2 says the initial number of bacteria in a petri dish is 200 bacteria and is decaying at a rate of 15% each hour. Approximately how much bacteria will be left after 1 day? Well, the decay function is Y equals A times 1 minus R to the X power. So what I'm going to do is plug in each of the pieces that I know. I know my start is 200 bacteria. And then I have 1 minus. My R is my percent as a decimal. So 15% as a decimal is 0.15. And X, the power of X, is time. Now it does give me time. It says 1 day. But we're not going to use X as 1 because it's changing 15% each hour. So 1 day is the same thing as 24 hours. So this exponent here should be a 24. Now decimals is a calculator, so all we have to do is type that in and it will evaluate that for us. And then again, to get the exponent, it's A to the power of B, and we want 24. So it would be 4.0465, etc. So based on these answer choices, the best answer here is B, about 4. Oh, wait, look, D says 4 as well. Let's change that to 46. So it definitely has to be B, 4. All right, we have 2 more examples. Now these are tricky because of the years, but that's okay. Since 1985, the daily cost of patient care in a community hospital in the U.S. has increased about 8.1% per year. In 1985, such hospital costs were an average of $460 per day. Find the approximate cost per day in the year 2000. Okay, so we are dealing with a growth because it says the word increased. So we know we're using Y equals A times 1 plus R to the power of X. Now I need to plug in each piece that I know. The starting cost was about $460 per day. Now I need my R, which is my percent as a decimal. So again, to do 8.1% as a decimal, just divide that by 100. So that's 0.081. and then I have a power of x, which is time. So here we're dealing with years. We have a start year and an end year. So my x is going to be just the difference between those years. So 2000 minus the start year, 1985, which is 15 years. If you don't want to do the mental math, you can type that into Desmos, which is 15. So that means our x, our time, is 15. So let's type this in to Desmos. We have 460 parentheses 1 plus 0.081, and then our exponent is 15. So that's 1,479, which would be A, because it does want the about or the approximate. So A is our answer here. We have one more example. Number 4 says, let me X out of these. In 2017, you purchased an iPhone 10 for $1,200. The value of the phone decreases in value by 40% each year. How much will that iPhone be worth in 2021? All right, so this is a decay. Oops. 1 minus r to the power of x. Now let's type in everything that we know. We know that our start is 1,200, and then we have 1 minus. Our r is our percent as a decimal, so take 40%, divide it by 100 to get that decimal of 0.4. And then our exponent of x is time. So if I want to figure out that time, I have 2 years. I have a start year of 2017 when the phone was first purchased, and then the year that I'm trying to predict for. So I need to see how many years are between that. I can really just subtract those. 2021 minus the start year, 2017. So 2021 minus 2017. So that exponent should be a 4. Now we can type it into Desmos and solve. And the exponent button is here. So our answer is $155.52, which would be C. So there were your 4 examples on creating exponential equations and using them to solve problems.